Hey there. Today we're going to talk about rational expressions. We're going to talk about what to exclude, how to simplify them, and we're going to talk about how to multiply them as well. Now, a rational expression is nothing more than a fraction meeting a polynomial. Okay, so if we combine those two concepts together, we're going to have what's called a rational expression. So the first thing that we're going to become skilled at is thinking to ourselves about what would we have to exclude from the domain of a rational expression. To do this, we are going to look at or examine the expression's denominator. All right, we're going to look for any value that would create a 0 in the denominator. Okay, and why is that important? Well, denominator. We know that we cannot divide by 0. So if we substitute a value in for x, it's going to cause a 0 in the denominator. That would be problematic. So we want to exclude that from the domain of our rational expressions. So let's think about this first example. We've got 7 divided by x plus 5. And we want to think about, okay, what would cause a 0 in the denominator? Now, a really easy way to think about that is just say, okay, well, we want the denominator not to be 0. Take that denominator and set it not equal to 0. And then just solve it like it's an equation. Subtract the 5. And we'd say x is not equal to -5. Well, that's pretty easy, right? Okay. And that's really all you got to do here. You want to solve that denominator for anything that would create a 0 and exclude it, make it non-equal. All right, so how about this one? X squared minus 36. Take that denominator and set it not equal to 0. Okay, so let's take this. I think we know how to factor this by difference of squares, right? We can call this x plus 6 and x minus 6 cannot equal 0. So here x plus 6 could not equal 0 and x minus 6 could not equal 0. So x cannot equal -6 and x cannot equal 6 or else we're going to have a problem here. So we can just say -6 comma 6 as our exclusions to our domain. Okay, how about this one? X squared minus 5x minus 14, let's set that not equal to 0. All right, so I think we're going to have to factor this one. So let's think about what multiplies together to make 14 but subtracts to make 5. Factors of 14, 1 and 14, 2 and 7, and I think that's it. Which one subtracts to make 5? I think that we'd have a 7 and a 2 here. And the larger one would take this sign, minus, plus, can't equal 0. Okay, so take each of these, can't equal 0. So x cannot equal -2, x cannot equal 7, and that would be our exclusions to our domain. All right, so the next thing we're going to discuss then is how do you simplify a rational expression? Well, what does that mean? What does it mean to be simplified? Well, a rational expression is considered simplified if the fraction has no common factors in the numerator and in the denominator. So to simplify, there's a couple of things we want to do. First, we want to factor both the numerator and the denominator. And then, anytime that we see a common factor, we would want to cancel it. So we would cancel out any common factors. All right, so let's give this a whirl. We have two examples here that we're going to work through. Let's look at this first one, x cubed plus 3x squared divided by x plus 3. So we're going to take this first one, we're going to look at the numerator, and I'm going to use this as my fraction line, okay? We're going to think about what can be a common factor of x cubed plus 3x squared. And we know that to be x squared, right? And if I factor that out of the top, if I factor the x squared out of the x cubed, I get x. And if I factor it out of the 3x squared, I get 3. So I've got x plus 3. Now on the bottom, I have x plus 3. Well, I have a common factor on the top and the bottom, so I'm going to cancel both of those out. And what's left is my x squared. And that's really about as easy as it is. So with b, it's the same idea, but I think this time we're going to have to factor both the top and the bottom. On the top, we're looking at x squared minus 1, which is a difference of squares. So we can factor that as x plus 1 times x minus 1. And on the bottom, it's not a difference of squares. I'm looking for factors of 1 that add to make 2. Well, there's only 2 factors of 1. It's 1 in itself. So this would have to be x plus 1 times x plus 1. Okay? So I have this fraction and a rational or polynomial expression on the top, which has been factored, a polynomial expression on the bottom, which has been factored, and now I'm looking for common factors that I can cancel out. And I find that in x plus 1 on the top and the bottom. So my answer is going to just be x minus 1 over x plus 1. And now I'm good to go. Okay, the last thing we're going to do in this video is we're going to talk about multiplying rational expressions. And this isn't too difficult to do. Remember that if I'm multiplying two fractions, like, I don't know, 2/3 divided by, or multiplied by 4/5, then really what I'm doing here is multiplying the numerators together, or 2 times 4, and then putting that over, or dividing by the product of the denominators, 3 times 5. So we'd end up with something like this, 8 over 15. This is true with rational expressions as well. So if I am finding the product of two rational expressions, it's just the product of the numerators divided by the product of the denominators. All right. And to multiply, when we've got rational expressions, often it's nice to be able to see all the factors, because then we can cancel things and not have to actually multiply things that would have canceled anyway. So the first thing we're going to do is we're going to factor the numerator and the denominator. And we're going to assemble them into one large fraction. So a single rational expression. Okay. And the next thing we're going to do is we're going to cancel any common factors. And the last thing we're going to do is then multiply anything that remains. So we're going to multiply the remaining factors in the numerator and we're going to repeat that and do it in the denominator as well. Okay, so this is the technique that we're going to use to multiply rational expressions. Let's try an example. Okay, in this case, we have an example of multiplication of rational expressions. So what I want to do is I want to factor everything I see. I want to factor numerator, denominator, numerator, and denominator. And when I do that, I'm going to write it as a single large fraction, okay? So my first numerator does not factor, it's factored. So we're just going to place it in a set of parentheses. My second numerator factors into x minus 3 times x plus 2. Okay. Now I'm looking at the bottom and I'm thinking about all the things that these things factor into. This x squared minus 4, that's going to factor in x plus 2 times x minus 2. And then over here we've got x squared plus 6x plus 9, which we know is going to factor into x plus 3 times x plus 3. Okay, good deal. Now we've got everything factored and it's in one fraction. So now I'm going to look for any matches that occur in both the numerator and the denominator and cancel them out. X plus 3 here will cancel with this x plus 3, or you could have used this one. This x minus 3 does not cancel at all, but this x plus 2 does cancel with this x plus 2. Now on the top, I'm just left with this single expression of x minus 3. And on the bottom, I'm left with x minus 2 times x plus 3. And I will need to go ahead and multiply that out for my final answer. And I end up with x minus 3 on the top and x squared plus x minus 6 on the bottom. And that would be my final result.